Well, thank you very much for joining the session today. Very happy to have the opportunity to share with you some of our latest products and partnerships. I'm just going to take a few minutes first to introduce Edutech and what we do, and then we have our colleagues from VRLab Academy joining us today on the call. So we'll hear a bit more about their organization and the work they do, and also have a look at how the labs work. And we'll have some subject experts from different disciplines to walk us through the labs. And also towards the end of the session, we'll be able to share with you personal access details so you can have the chance to experience the product for yourself as well. So just to begin with, Edutech, in case you haven't come across us as yet, I'll just give you a quick introduction to what we do. We're based in the UAE, in Dubai, established in 1991, and we focus on educational technology across schools, vocational institutes, universities, and corporate companies as well. So we've gained a lot of domain expertise in terms of educational technologies. We're very fortunate to serve some of the largest clients in this region. We do set up physical labs as well, but today really we're going to show you what the future may look like in terms of education. Just to give you a quick overview of our portfolio of products and services, we deal with universities in multiple areas. So within digital learning, immersive learning, various types of platforms that are very key today for delivering 21st century education. And then in terms of hands-on education, we've had a long experience of setting up labs, various kinds of engineering labs and vocational labs as well. And it really brought us to looking out for what are the best solutions in the market, and how we can add value to institutions over here. And really that's how we entered into a partnership with VRLab Academy. VRLab Academy is one of the most innovative companies operating in the space of developing virtual labs and serving some very prestigious universities in the world today. So we'll be hearing more from them. Please do feel free to ask questions as we go along. If you missed something and you would like us to go over it again, more than welcome to do that. We will drop our contact details in the chat as well. So please feel free to reach out to us later on once you're going through the labs. If you have any more questions, we'll be very happy to arrange a separate session with you and answer any questions. So I'd like to hand over to my colleague Emine to begin the session.
Thank you so much, Faisal. Thank you. Hello, everyone. Thank you for joining today to this meeting. I will give a brief presentation about our product, and then we will continue with showcasing the platform and a couple experiments from different fields. So I would like to share my screen. So as VRLab Academy, we are developing virtual reality science experiments, and these are some examples from different schools. You can see the physical usage inside of the school building in VR classes or in lab classes that our software has been used. This is from a medical university. Recently, we have switched our platform to web-based systems. So it's like any other website that you use. You just log into the system, and then you can use all of the experiments. You don't need to install anything to your computer. And then you will be coming across with two versions that we have, VR version and PC version. And when we continue, we will be seeing the laboratories. Right now we have 10 laboratories from 10 different science fields. And when you choose the laboratory that you purchased, you will be seeing the experiments. We have a small explanation here at the beginning, and we have two buttons as start and manual. When you click to manual button, you will be seeing the experiment information form. The students can download these information forms and they can check the theoretical explanation, the steps and procedure of the experiment, and they can get the blank versions of the tables and graphs that they are seeing inside of the laboratory, so they can fill them and they can use it as a lab report by sharing it with their professors. And then you can also start the experiment with start button directly. These are the experiments that are available for high schools and universities currently. I'm sure Edutech will be sharing this information with you if you would like to check it in detail. And we are also producing and developing elementary and middle school experiments too. So in the portal, when you enter, besides of the laboratories, you will be seeing 3 other sections. My data section includes the data that you received from the experiment. Live section includes the experiments tutorial videos that our science team records, and VRLab Academy webinar, we share our webinar series. So this is from the live section. You can see this experiment tutorial videos for each experiment. And I would like to show some screenshots from the lab environment while our science team will be demonstrating the experiments in a while, but for you to get acquainted with it beforehand. So you can see we have a tablet on the experimental desk, and you can find the theory part that I mentioned as placed in the experiment information form inside of the laboratory too. So you can check the theoretical information and experimental procedure, and the experiment part contains the tables and graphs. So as you know, and many of these experimental kits are quite expensive to have. Not all of the students can access to those materials, and you have to buy consumables every year. You cannot observe things that you can observe virtually in real life in biology. We also have Popular Science Laboratory. This is more for general science knowledge for smaller children. And this is the sensors that we have. We have more than 100 sensors inside of the laboratory. These are like heat sensors, Geiger-Müller sensors that are also quite expensive in real life and hard to find. So the student can decide whether they need these sensors to be implemented to the experiment, and they can go grab it and use it for their experiment. We also have a lab assistant, Amy. She walks students through the experiment. She gives small information about the experiment and also the steps that you need to follow. We have a video that shows the PC usage. It can give you an idea. These are the students that are using basic electricity experiment. They are arranging the cables on an electrical circuit, and they are changing the voltage. They can also check their data in real time, and they can note that change. So this is the theory part that I mentioned. We have several language selections, so you can select the language you want to perform the experiment, and then you can check the theory part and the tables and graphs. This is from the photosynthesis experiment. They are using the sensors for oxygen and carbon dioxide. And an example for VR version. So for some customer impacts, while you are using VRLab Academy, you don't need different physical classrooms or laboratories to be able to perform these experiments. Students can perform the experiments from their home or at school. As long as they have a computer and an internet connection, they can perform it anywhere. And also the the academicians can give homework to VRLab Academy because the experiments work with real formulas and they give real scientific results, just like a physical laboratory. And also you don't need any space or storage for the consumables. Academic collaboration is an opportunity and many more. So this is a research that held in Japan, Saga University. They took EEGs of the students, and the EEG data shows that students in VR classes are 6 times more concentrated, and this concentration maintains longer. We also have curriculum correlations. Our science department do the mapping, so the academicians can see which VRLab Academy experiments correspond with which titles in their curriculum. We also have LMS integration opportunity. So when you have a LMS system that you use in your school, we can integrate VRLab Academy to that LMS, and it becomes single sign-on, so you don't have to put your username and password each time you enter. Also, some more data is viewable by the academicians through this LMS integration. For the academic collaboration opportunity, if we don't have the experiment that you want to study on, we can develop this together. We just get the theoretical information and some more information from you. We set a couple meetings, and our team designs and do the software part of this experiment, and then we publish it from our website. This is an example for a medical biochemistry laboratory that we developed with a medical school with 3 professors, and this is a spectrophotometry experiment that we published from our website. We also globally partnered up with Intel and Lenovo. This is from 2020 Vet Fair London. And there is a artificial intelligence science league that is really important for us, that will be done among the VRLab Academy users, students, groups, and we will be sending 3 different artificial intelligence problems, and they will be sending their solution algorithms to us, and our academic panel will check it, and the Science League final will be held place in Fundamental Science Museum in Germany. Thank you for listening to me. So right now we can pass to our science team. They will be showing the interface to you. They will also show you a couple experiments from different fields. We can start with EDGE, and we can start with biology experiments. Then we will be passing on to chemistry and physics also. So if you have any questions during the experiments also, please don't hesitate to ask. We'll be glad to answer them.
Hello, I am Ece. I am graduated from Molecular Biology and Genetics Department, and I am currently working on the VRLab Academy Science Department. So first of all, I need to share my screen. I'm not the host, so I can't share my screen.
Just give me 1 second. Let me do that.
Thank you, Faisal. I think you can try again.
Yeah.
I can't share my screen. Yeah. Okay, I think you can see my screen now.
Yes.
You can.
Okay. First of all, when you log into the VRLab Academy, you will see 2 different options. Here, VR version and the PC version. I will continue with the PC version. Then you will see the different laboratories in here: biology, chemistry, electric, and also we have a junior for the elementary schools. And also you will see the My Data section in here. You can save your data and you can upload it into your own computer when you complete the experiment. Also, we have a VRLab Academy Live section here, and you can follow the videos of the experiments in here. And lastly, we have a VRLab Academy webinar section. So we are doing a webinar series and we will upload the new videos in here. So I will start with showing the experiments to you. First of all, I will perform the introduction to library and solution preparation experiment. So when you click on the picture of the experiment, the tool button in here will be activated. When you click on the manual, you will see the manual of the experiment in here, and you can follow the theory and tools and materials and the experimental procedure in here. And you can also see the short description of the experiment in this section. So when you click the start experiment, the experiment will be activated, will be open. And you need to use this blue button in here to maximize the page. So when the experiment is open, you will see a language selection screen. I will continue with the English, and Amy will start to give an information about the experiment.
Hello. Today we are going to familiarize ourselves with the laboratory equipment and rules for safety. Next, we are going to prepare our first solution. Our first solution will be a buffer solution. You can use the tablet for detailed information and start the experiment.
So you need to use the A, S, D, and W keys on the keyboard to move in the laboratory. A for left, D for right, W for forward, and S for backward. And you will adjust your pH with your mouse. So first of all, we need to read the theory part of the experiment. So you need to use the left button on your mouse to take something to your hand in the laboratory, and you need to use the right button on your
Let's start with
mouse
learning
to
the
leave
tools in the
it.
laboratory. What was our first rule? Personal protective equipment. You can use the gloves and lab coat near the entrance.
So in the introduction part, you will see the same
You
manual
can use
in
the
the
gloves
tablet.
and lab coat near the entrance.
You can also follow the experiment in here. So we need to first to wear the lab coat and the gloves to start the experiment. Then for this experiment, we will introduce the lab materials.
You can use the gloves and lab coat near the entrance.
When you take the first material, the pipette, to your hand, the informative box will be open and you can read the information about the material. So I will take them respectively and follow the informations in here. You need to take to all of them to activate the second part of the experiment.
Now we are familiar with the laboratory.
And also
Now
Amy
we can
will give
proceed to
a
prepare a buffer solution.
warning.
You can start the second experiment from the tablet.
So Amy also give a warning and the tablet will be highlighted to blue. So now we can prepare the buffer solution. We can also see the tools and equipments and the experimental procedure in here. So first of all, I need to put all of the solutions to analyzer. To take the solution from the bench, I need to click the left button on my mouse. Then I will go to the analyzer and place it. Then the name of the solution will be appear. Also, it will be labeled on the desk. So I will need to put the now I can weigh my sodium carbonate in here in the digital way. So I will use the spoon to take some sodium carbonate in here and I will place it. Then I will take it and I will put it into my solution preparation beaker in here. Then I will place the water. And I can start the pH meter. The pH meter will be mix the solution and also it will read the pH of the solution. So I can add in here acid to change the pH. So we need to use the pipette. I will place it to the blue highlight in here and we need to use these arrows to take some liquid. I need to use the upper arrow in here to take the liquid from the beaker. And I can add to my solution with the the bottom arrow in here. Then the liquid will be placed in the solution. And also the pH value decreases. I can also add more acid to decrease the pH level. So you can also see in here the pH values decreases real time. When you completed the solution preparation, you can turn off the pH meter. Then we can place the extra liquid into the liquid waste in here. Then also place the beaker into the washing dish. So the student can see the cleaning part of the experiment. So this is the end of the experiment. If you have any questions, I can answer it or I can continue with the second experiment.
I think we can continue, Ece, maybe at the end of the biology experiments, after this next experiment.
Okay.
They might have questions.
Okay. Also, we have 3 different buttons in here. I can also tell them. With the reset experiment button, when you click on it, all of the equipments will go to its initial positions and you can perform the experiment again. Then also we have a restart experiment button. When you click on it, you will go to the language selection screen. And lastly, we have an exit experiment button. When you click on it, you will go to the first laboratory page. And now I can perform the qualitative determination of carbohydrates experiment. Also, in here, 2 different buttons will be activated and you can follow the manual in here. And you can see the short description in this part. So then I will start it. You also need to use this blue button to maximize the page. So I'll continue with English.
Hello there. I see a science enthusiast. Welcome to VRLab Academy. I'm Amy, your lab assistant. Today we will perform qualitative analysis of carbohydrates with you. Carbohydrates are polyhydroxyalkyls that carry an active aldehyde or ketone group. Carbohydrates are also reducing sugars. When briefly called reducing sugar, we should understand that there is an aldehyde in a solution or any sugar that has a ketone group. The Fehling test, Benedict test, and Barfoed test are often used to detect reduced sugars. We'll do the Fehling test in our first experiment. Please read the general information on your VRLab tablet.
When Amy completes her speech, the tablet will be activated. We need to check the theory part first of all. Then we can wear our lab coat and gloves to perform the experiment. For this experiment and for
You need to label the reagents you're using.
all of the experiments, you need to use the same keys, A, S, D, and W, and your mouse to move around the laboratory. So Amy also said we need to analyze all of the solutions.
You need to label the reagents you're using.
You will see the name of the solution in your desk and in the analyzer in here.
You need to label the reagents you're using.
So failing A. The last one will be the failing B.
Please refer to your VRLab tablet for the failing test protocol.
Then we need to check the failing test protocol, our tablets. So also I will take my pipettes and place into the 0.01 molar glucose. And I will also use same buttons in here to fill my pipettes. I will put 2 milliliter of 0.01 molar glucose to one test tube. And I will change my tip of my pipette. Then I will take my second solution. And I will place it into the second test tube. Then I will add the failing A, 1 milliliter failing A to each test tube.
You can't leave a straw with liquid in it.
Also, Amy given warning. Then I will add the failing B to each test tube now.
You can't leave a straw with liquid in it.
Then I need to heat the both of the test tubes. So I will open my Bunsen burner. Then I will take the test tube and place it into the heat. Then we need to wait 30 seconds to see the color changing in the test tubes. And the 30 seconds completed, you can take it and you can heat the second test tube.
Why do you think a darker color was formed in the second test tube?
So Amy explained the color difference in here.
The aldehyde and ketone groups in the sugar structure reduced the hot basic Cu+2 ions to Cu+1 and formed color. When we compare the first test tube and the second test tube, we expect the higher sugar to be darker. Therefore, the second test tube we prepared in 1 molar glucose solution gave a darker color. In the second experiment, sucrose, a disaccharide, glucose, and fructose. We'll do the decomposition experiment. Now, please check the general information and test protocol from the VRLab tablet.
So
Let's perform the experiment.
we can continue with the second part of the experiment, cross inversion. I will click it, and you can follow the protocol in here. Also, the solutions will change. We need to label them again. The first one is hydrochloric acid. Second solution is sucrose solution. Now I will also add 2 milliliter sucrose solution in each test tube.
You should change the pipette tip when switching to a different solution.
Also, we will use the same buttons to fill and place the liquid into the test tube. Then I will take my Pasteur pipette to add HCl solution. Then I need to heat the first test tube to induce the sugar. Also, we need to wait 30 minutes. 30 seconds, I am sorry. I can close my Bunsen burner for now. Then I will add 1 milliliter Fehling A.
You should change the pipette tip when switching to a different solution. You can't leave a straw with liquid in it. You should change the pipette tip when switching to a different solution.
Lastly, I will add the Fehling A, and I also will heat both of the test
You can't
tubes.
leave a straw with liquid in it.
Now I can open the Bunsen burner, and I will heat both of the test tubes to see the color changings also. You can see the color is changing now. I can switch to my second test tube. In this test tube, there will be no changing, so So we will see the difference in here also. It's the end of this for experiments. So in here also we have a reset experiment button. All of the equipments will turn the initial positions. And we have also restart the experiment button. With this button, we can turn back to the language selection screen. Also, the exit experiment button, we can turn back to the main laboratory, biology laboratory. So this is the end for my presentation. If you have any questions, I can answer it.
Thank you, Ece.
I think we can move to the next part.
Okay.
Okay, we can carry on with chemistry experiments. Deniz, you can share your screen and unmute yourself.
Thank you, Mina. I think that I have to be a host to be able to share my screen.
Faisal, can you please change Deniz?
Thank you.
Okay.
So can you see my screen now?
Yes.
Thank you. I'm Denise. I'm a chemical engineer and work in the VRLab Academy for chemistry department. And I will show you 2 experiments today. I'm using a PC version, so I select PC version after logging in as Ece has shown. But it turned me back because I was waiting too much. So I log in with my username and password, select my version that I want to. I go to chemistry lab because my experiments are in chemistry lab. And the first experiment that I'm going to show is a space experiment. So I find my experiment, click on it, and select. I can find my manual in different languages in here in manual button, or I can start the experiment using the start button. I go on full screen using the blue button on the bottom. And I can select the language that I'm interested in the language selection screen. I continue with English. Here we meet Amy.
We cannot hear Amy, but you can continue. Deniz, the attendees will be checking this experiment so they can hear it when they do the demo version.
Okay.
You can carry on.
I think that I had to arrange the settings before. So Amy gives some theoretical information about the experiment, but we can find more detailed information about it in the digital tablet in front of us. In the theory section, we can find some theoretical information. We can see the tools and materials that we are going to use. And we can see the procedure that we have to follow. We are going to perform a titration using hydrochloric acid and sodium hydroxide. And we can select between different indicators for this titration. But first of all, we have to see what are the materials provided in the beakers. So we take each beaker and put it inside the analyzer. And learn the name of the content inside the beaker. So we find out that this is sodium hydroxide of 0.1 molar. In the small beakers, we have the indicators. this phenolphthalein, we can find out that it's phenolphthalein putting it into the analyzer. And we can see that the name of the contents are written on the table in front of us. These are the other indicators. This bromcresol ring, so this bromthymol blue, and the final indicator is Congo red. Finally, we find out that we have hydrochloric acid inside the last large beaker. In order to start the titration, we have to put sodium hydroxide into the titrant part. And we have to put hydrochloric acid inside the analyte beaker. In order to observe the pH change during the titration, we have to select one of the indicators provided, and we select phenolphthalein as an example. The blue labels help us continue with the next step. So the titration setup is ready, and we press the button to see how the titration is performed. We expect phenolphthalein to change color around 8.5. You can also see in here on the board the change in volume, actually the total volume inside the beaker, and the pH value. The change in color has been performed as we expected. The pH value continues to increase because we add sodium hydroxide, and the titration is completed. We go back to the digital tablet, go to the home screen, and you can see that the data has been saved inside the table inside the tablet. We can save the data in the My Data section as Ece has shown, and we can also draw the titration graph as shown in here. So this was the titration, the acid-base experiment. We again have the reset experiment button and the restart experiment button in here, but it moves us to the language selection, and the exit button that we have to press to exit the experiment. So if you don't have any questions, I can move to the second experiment.
I think we can move on, Dennis.
The second experiment that I'm going to show you is the ideal gas laws. We again find the manuals in here in English and Turkish, and we can continue with the start button to enter the experiment. We move to full screen, continue with English, and enter the lab that Amy meets us. We meet. She gives some theoretical information about the experiment. We are going to observe the difference in different states for ideal gases. Here we find the theory part, the laws of Boyle, Charles, and Gay-Lussac, the tools that we are going to use, and the experimental procedure that we have to follow. We go back, and in order to start each experiment, we have to press on the tablet. The tablet turns blue and shows us that we have to press the tablet, and we go to the experiment part and choose the measurement that we have that we want to make. We start with the Boyle's law. As we see inside on the table, the temperature should be arranged to 30 degrees Celsius. We are going to change the volume and see how the pressure changes for this measurement. Let's firstly observe the setup. You can hereby see a piston. Inside the piston, we have helium, which resembles ideal gas behavior the most. And we have a jacket, heating jacket, which we use to heat and cool the helium gas inside the piston. We have to arrange the temperature to 30 degrees Celsius, firstly, to be able to start the Boyle's law experiment. And as you will be seeing in here, we have to change the volume firstly. Each time that we change the volume, we can observe the difference in pressure, and we can save the data point using the button in here. So we continue changing the volume. The pressure changes. You can see it inside on the sensor in here, and we save the data. We have to save 3 more data. We change the volume, observe the pressure difference, and save the data. Do the same thing again. And take the final data point and go to our table. You can hereby see that when we increase the volume, the pressure drops, as we were expecting for the gas. We can save our data using the button here, and we can also draw the graph using the draw graph button. You can see that the pressure drops with increasing volume. In order to continue with the second part, we have to go to the digital tablet, go back, and go to the Charles law measurement. Here we have to arrange the pressure to 2 atmosphere. We are going to change the temperature and see what happens with volume. So we go to 2 atmosphere. Let's firstly get the first data point at 30 degrees. Change the temperature, increase it. The ranges that we can select for each variable are written on the tablet in the procedure part. So each time that you are confused, you can go back to the digital tablet and remember. And the last data point. You can hereby see that the data is saved. We save the data. We can access the data on the My Data section and draw the graph. You can see that as the volume increases, the temperature actually increases, the volume increases as we are expecting. In order to continue to the last part, Gay-Lussac measurement, we have to select the Gay-Lussac measurement, arrange the volume to 5 liters using the arrows, change the temperature, and see what happens with pressure. Let's get our first measurement. I'm going to decrease the temperature by means of simplicity and save the data using the button here. I observe the pressure change. I decrease the temperature further. I expect the pressure to increase with increasing temperature because the molecules have more energy moving. I see that my table is completed. I observe that as the temperature increases, the pressure increases. I save my data and I draw my graph. So that's all. I can reset the experiment. So start again, restart the experiment and select language again and exit the experiment using this button here. Thank you very much. I will be happy answering your questions if you have any.
Thank you, Denise.
No problem. So I stop sharing.
We can continue with physics.
So hello, I am Kıvanç. I'm a theoretical physicist by training. Graduated from the Technical University of Kaiserslautern in Germany. I myself conduct research on theoretical physics in areas such as differential geometry and black hole thermodynamics. And here I am the head of the physics department at VRLab Academy. And today we'll be looking at 2 experiments from physics. One will be from mechanics and the other is going to be from electromagnetism. So let me start by sharing my screen. And hopefully you are now seeing my screen. Now here we have our lab catalog. So first of all, I'm going to choose the mechanics laboratory. And from the mechanics laboratory, we will be looking at the Airtable experiment, which is located here. So I select the Airtable experiment and click the Start button. So the experiment is starting. Now I go to full screen by clicking this blue button. And then we can start by selecting the language that we want and enter the laboratory. So this is the lab setting for the Airtable experiments. we again have Amy, our lab assistant. And here we have our VRLab tablet. We can view the theory part, the procedure, and we can view the experiment part. Now here in this experiment, we have 3 different parts. And these parts are on motion with constant velocity, the first part. Second part is on motion with constant acceleration. And last part is on the conservation of linear momentum. So let me select the first part on motion with constant velocity. Now we have our empty table. I drop the tablet with the right mouse button, and then I will start conducting the experiment. Now here in this first part, we will be using this air table to the right. And the way we are going to use it is like this. So we will take one of these pucks into our hands by clicking with the left mouse button. And then appears the blue highlighted region where we can drop the puck. So again, by clicking with the left mouse button, we throw the puck. And then a set of measurements are taken on this air table. And at the same time, the measured values of position and time appear in our tablet. And using the tablet, we can click the Draw a Graph button to see the plot of the experiment on the board. Here we have the position versus time plot. And as we can see, it is a straight line, which means that the puck moved with a constant velocity. And using the slope of this graph, the student can actually calculate the velocity of the puck. Now, this is basically the first part of this experiment, but we can also repeat this experiment or repeat this part with different initial conditions. So for instance, first of all, we can reset the experiment whenever we want using this reset button. And then we can increase or decrease the launch force, which changes the initial velocity of the puck. So for instance, if we release it with 4 times the velocity, as you can see, only one measurement could be taken. Now we can, if we want to measure more points with this initial velocity, what we can do is we can increase the frequency. So here we have the spark timer, whose frequency can be adjusted. Now let's, for instance, adjust this to 30 Hertz, and now repeat the experiment. And as you can see now, so as you can see now, the frequency of the measurement points is higher, and so we can take more points. And if you now draw the graph, you can see that the slope of the graph is much higher, which corresponds to the higher initial velocity.
I'm sorry, could I just interrupt for 1 second here?
Sure, please.
I realize that we're getting a bit over the time, so I just wanted to, we will continue, and if the guests could stay for another 10 to 15 minutes so we could complete this, but in case anybody has to leave, your password for accessing the VRLab Academy content is VRLab Academy in small caps, and the username is what you have used to register for this session, your email address. If there's anybody who's joining who didn't fill out the form and register, just please drop us an email and we can have your account set up for you. And if you have any trouble or you're not able to access it for some reason, I'll put my email here in the chat as well, and you can contact me for direct support. Yeah, so please continue.
Thank you, Faisal. We can finish this experiment and then directly go to the questions if you want.
That would be
and not perform another experiment. Okay, we can carry on, Kıvanç.
Okay. All right, so this was the first part of this experiment. Now let's have a look at the second part. In the second part, we have motion with constant acceleration. Now let me again drop the tablet with the right mouse button. Now here, to work on acceleration, we are going to use this airtable to the left. Now this airtable can be tilted by using the left mouse button. So if we click and hold with the left mouse button and drag with the mouse, we can adjust the angle of this table to any value that we want. And after we tilted the table, we are going to take this puck, again with the left mouse button, and we can now see the highlighted region, and we click that region with the left mouse button. And so the puck moves on the inclined airtable. And here again, we see the position and time measurements. And again, we can draw a graph, but this time, this is position versus time squared. And so we can see that since this plot is a straight line, we can see that the position depends quadratically on time when the motion has constant acceleration. And similarly here, the students can measure the slope of this plot, and from that slope calculate the acceleration. So that's the second part of this experiment. Let's quickly have a look at the last part. This is the part on conservation of linear momentum. So here we go back to this airtable to the right. Now we want to collide these two pucks, and we want to measure the velocities before and after the collision. Now the way we can do this is by clicking this button which says Start Collision. If we click with the left mouse button, we see the pucks moving and colliding. And now if we take the tablet into our hands, what we can see is the velocities of two pucks before and after the collision. And we can indeed see the X and Y components separately. So here the student can add up the X components and the Y components separately and check whether they get the same thing before and after the collision. And in this way, they can confirm the conservation of linear momentum. And that completes the third and last part of this experiment. At this point, if you have any questions, I would be glad to help.
Thank you, Kıvanç.
Thank you for listening.
So thank you very much once again for everyone who's joined us for this session. Please feel free to ask any questions you have right now. Otherwise, you should be able to log in to your accounts from VRLab Academy website. The password is VRLab Academy, all in small caps, and it's in the chat box. We'll be sharing with you a recording of this session and following up on emails. So please feel free to reach out to us. We hope you get the chance to use the labs and experience it for yourself. I don't see any questions coming in, so I think we will just give it a few more minutes before we close the session today.
Okay, of course, Faisal. And I also would like to thank everyone who attended and to Edutech in the name of our team. It was really nice to attend this meeting today. And if any of the attendees have any questions also for the further time, you can reach out to Edutech and we can have additional meetings if you or your institution needs.
Hello.
Hello, Doctor.
Hi. Thank you for this session today. Just I have one question. If we use a VRLab to teach the student, my question is that how we can assist the student in this type of lab. You see what I mean? Okay, we can have outcome of VR lab like compared to traditional lab, but how we can assist the student in the future if we have like you understand, you got the idea what I'm meaning.
You mean about the experiment and how to perform and if they are doing anything
after
wrong?
they
Yeah.
learn, how we can assist them.
Well, in this remote learning times, this distance learning times, due to a pandemic process, the schools usually use this way of the platform in this kind of a Zoom meeting or a distance learning lesson. Before the academicians schedule, we schedule couple meetings for the training, and we give the instructions and training to academicians and professors that will be using the VRLab Academy platform. And the academicians are sharing their screen. They are performing the experiments with explaining it to the students, and then students, it depends on your like choose of usage, but during the class, the students can also share their screen and show you that they are receiving the data, or you can share your screen and perform the experiment with explanation, and then they can perform the experiment as a homework and they can share their data with you. Or they can use it during the class. So actually the students, the professors are getting the evaluation from the screen sharing and also from the data, because the students can download these experiment information forms and they can fill the tables and graphs accordingly to the data they received, and they can share it with you. So you will be seeing their data, and it's not possible to receive this data if you are not performing the experiment. So this is how schools and professors usually do in these times.
Sorry, another question as well. I want to ask, is there a specific number for a student to enjoy the VR lab, or?
No, if you purchased a laboratory or an experiment, you can perform this experiment as much as you can, as many times as you want to perform, and you can actually interrupt the experiment and then continue again and anytime you want. So they can perform the experiments millions of times. It doesn't have an exact number.
Sorry, I mean the number of the student. Like I'm giving the live lecturer on the particle lab, okay, VR lab, and then I want them to participate with me and sharing their screen with me. I mean, how is the capacity of the program to accept the student? You see what I mean? Like
I think about the licensing, Faisal. Am I hearing correct?
So your question is regarding how many students can access it at the same time, one experiment.
Yes. This is my question. Yeah.
There's no limit on the number of students. So because it's accessed through the internet, every student will have their own account and they will be performing the experiments at their own pace. So it's designed really to scale up So you can have a lot of students doing it at the same time. That's really the powerful part of the virtual labs. You don't have the same restriction like what you have in the physical lab, either with space or with resources. So there is actually no limit to how many students can access it.
Yes, exactly.
Okay, how I can make sure the student doing well in the lab? So
by the data that they received, actually, they can manipulate the inputs, so they can change the inputs that they are while they are performing the experiment. So each student can get different outcomes from the experiment. And also with the data they receive, they have their names written on it automatically, like as a default. So when they download it and when they share it with you, you can be sure that they perform the experiment and receive the data.
yeah, okay, really thank you. Really, it's
Sure.
really useful. Yeah, useful information. Thank you.
You're
Yes,
welcome.
Doctor, you will have access to the labs. Please, you're welcome to try them and share with us your feedback. Is there any other questions at this time? Please feel free to chat, put it in the chat box if you would like. We'll just give a few more minutes before we close out. So thank you once again to our colleagues from VRLab for joining us today, and for all of the guests. We look forward to hearing from you. Please look out for our LinkedIn and Twitter and email communications. Hopefully we will be having more sessions with VRLab Academy as well. So look forward to seeing you there as well. Thank you so much and have a great day.
Thank you, Faisal. I also would like to say that the attendees can reach to their accounts and to the three experiments during this 2 weeks. So they can check it anytime they want in 2 weeks.
Thank you, Emine. Thank you.